Section 11.2, Box and Whisker Plots. What we're going to be looking at in this section is a way to represent a set of data. And the way that we represent this here is with two whiskers on the outsides and a box in the middle. And part of the key features here is that the box actually has another vertical line segment cutting through it, not necessarily directly in the middle of the box. Now there are 5 values we need to find in order to graph a box and whisker plot. That's the least value, the first quartile, which we call Q1, the median, which is Q2, also known as the second quartile, the third quartile, Q3, and then the greatest value. Now we call these quartiles Q1, Q2, and Q3 because they split the data up into 4 distinct regions. The left whisker, the left part of the box, the right part of the box, and the right whisker. And it's a pretty straightforward process in order to plot these. There's just 6 steps to consider here in order to find these 5 values that are going to give us what we call the 5-number summary of the data set. First thing we do is we list the data in numerical order. That's the same type of thing we would do if we were going to find either the range or the median. So that's something we've done before. And then we will actually determine the median, which is Q2. So once we do that, we cut this part in half, and we're going to have half of the data approximately on the left, half of the data on the right. So we take the first half of the data, not including the Q2, and figure out what the median is of that. And whatever the median is of that is going to be our Q1. We're going to do the same type of thing for Q3. Take your second half of the data, find the median of that half, and that's going to be your Q3. We'll plot our 3 quartiles on a number line, and we will also plot the least and the greatest values. Then we connect them in this fashion to make a box and whisker plot. Start at your least value, go out to your Q1, start the box, draw in the vertical marking at Q2, finish the box all the way out to Q3, and then extend the whisker to to the greatest value. So now that we've seen this in general, let's try to do a specific example, and we'll see that it's actually not too bad, and we'll go from there. All right, let's take a minute to talk about the Rocket. Roger Clemens, pitcher from Major League Baseball, had a 24-year career. Pretty remarkable career, a lot of accusations and suspicion of performance-enhancing drugs, but nonetheless one of the most dominant pitchers of his era. Pitched for 4 different teams. He started with the Red Sox, moved to the Blue Jays in Toronto, then went to pitch for the Yankees before going to his hometown, Houston Astros, and he actually finished his career back with the Yankees for a brief stint right at the end of his career. Anyways, over his 24-year career, he amassed quite a few wins. And this data right here is the number of wins that he was awarded as a starting pitcher each of his 24 years. And I want to take a minute to try to construct a box and whisker plot of this data. In order to do this, I'm going to start by writing these numbers in numerical order. That's our first step. So take a second and let's do that. All right, so now that we have these 24 numbers in order, we now need to determine the median. And since there are 24 numbers, we're going to go 12 in from either side, which is going to take us to this 17 and to this 17. I have an even number of data points here, so my Q2, my median, is actually going to be the average of 17 and 17, which is about as easy as it gets. But right in here would be my Q2, which is 17. So my second quartile is going to be 17. Now I'm going to look at the first half of my data. I'm going to look at just this right here, from 6 up to 17. And I ignore this at this point because that's a different value. I'm looking at these these 12 seasons, and I'm figuring out what's the median here. And so I'm going from 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I'm in between 10 and 11, and that's where I'm going to find my Q1, which is going to be the average of 10 and 11, so that's 10.5. And that's my first quartile. Same thing for my Q3. I find the median of the second half from 17 up through 24, and that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I'm looking at in between 18 and 20, and so that's going to be my Q3, which the average of 18 and 20 is 19. And so now I have 3 of my quartiles, or my 3 quartiles. I need just the other 2 values, which are the extreme values. Clemens' lowest win output was 6 wins, and his highest, his greatest, was 24. And so now I have the 5 numbers that I need in order to construct a box and whisker plot. So on the next page, I'm going to plot those 5 numbers on a number line, and then go from there. So here we have our data. We've got the least score of 6. So right above 6, I'm going to put a point right there. I'm going to put another one at 10.5, so just do my best to get in between 10 and 11. Another one, my median at 17. And Q3 at 19. And the greatest would be 24. So that's what I've got. Now I'm just going to connect this and make a box and whisker plot. So I make my first whisker, and I'll make my other whisker now too. And then I just make a box around here and draw a vertical line down through the median. So I have the least value, the first quartile, the second quartile, or my median, the third quartile, and my greatest. And that's my box and whisker plot. That tells me all that I need to know about this data. What I can interpret from this is, if I was just to look at this graph here, I could pretty easily figure out the range by subtracting the least value from the greatest. And the range would be just 24 minus 6, which would be 18. So the difference in wins from Clemens' best year to his worst year in terms of winning games was 18, which is a pretty high number, but probably not uncommon, since some of those low years involved limited work as only part of a season. I could certainly figure out the median, which would just be Q2, but I can't figure out mean or mode or standard deviation even from this information here. So that's pretty much all that it can tell me. The other thing that I know is that in each of my 4 sections, there's about 25% of his seasons. And so 25% of the seasons, Clemens was between 6 and 10.5 wins. In 25% of the seasons, he was between 10.5 and 17 wins. 25% of them between 17 and 19, and 25% of them between 19 and 24. And so actually, when you have a small section, it means that there's a lot of numbers in there that are really close to each other, as opposed to this, which is more spread out. And that's represented by, there was a few 18-win seasons that got stuck into there. And so that's how you would interpret the box and whisker plot. Hope this makes sense. Box and whisker plots can have a couple of different looks to them. Talking about skew, a box and whisker plot could be skewed left if the left side of it, the left box or the left whisker are larger. And what that means is that most of the data are on the right side of the plot. This is very similar to what we just saw with the Roger Clemens box and whisker plot, where the left whisker was longer than the right, and the left part of the box was larger than the right. Most of the data are on the right side of the plot. It's more highly concentrated on the right side as opposed to this, which is really spread out here, because there are the same number of data points in here as there are in here. That's what's to keep in mind. So that's called skewed left if it's longer left than it is on the right. Symmetric is about the same length. They don't have to be exactly the same length. It's unlikely that they will be exact, but about the same length, and the median is pretty much in the middle of the plot. It means that the data is pretty well distributed amongst all the different values, pretty even distribution, nothing too uncommon there. And we could also have a box and whisker plot that's skewed to the right, very similar to the skewed left. That's when you have just a couple of things that are really spread out over here, kind of make for a longer right whisker, and similar thing for a right part of the box. And in this case, most of the data are on the left side. Again, it's just highly concentrated here. So you just should be aware that if the left whisker is longer than the right whisker, then it's skewed left. And if the right whisker is the longer one, then it's skewed right. Otherwise, we consider the box and whisker plot to be symmetric. All right, so here's one thing that's really common with box and whisker plots is to actually put two of them on the same number line so you can compare different things. It's really probably the most useful application of them. We're going to start off by talking about two different classes here. Your class, taught by Mr. Calnan, and Friend's class, taught by another teacher who shall remain nameless, but we'll see which teacher is doing the better job. Based on these box and whisker plots, there's a couple of things we can figure out. We can figure out the range of each class's test scores, and that's just by doing the highest minus the lowest. So take a second, try to calculate those, and pause the video, see if you are able to get that range correct. All right, let's see how you did. All right, so for your class, I approximated that the low score was about 67. So we got a range of 33, and for the Friends class, the range would be 40. It just means that there's a little bit more spread out scores in your Friends class. The next thing to figure out would be what the median score was in each class. So once again, pause the video and try to calculate that. All right, how'd you do? So you can see here that in your class, there was a median score of 90. That's the Q2 here. And the median score in your French class was only 80. So what that means is that in your class, taught by Mr. Calnan, 50% of the students had grades 90 or above, as opposed to in your French class where only 25% of the students had grades 90 or above, 50% were 80 or above. So certainly not saying that your Friends class isn't taught by nearly as good of a teacher as yours, but something to keep in mind. Just another thought while we're looking at these here, it appears that your Friends class has a symmetric data set compared to your class, which appears to be skewed left. What this probably means here is that there's just a couple of low scores that were really kind of below what we would expect here. Maybe just this 167 was a student who had missed some time and had tried to make it up on his own time, and just didn't quite grasp the material. But that's the general idea. That's what you can gather from looking at this information from these box and whisker plots. There's no way to determine the mean or the mode, standard deviation. We can't determine those things from this. We can probably approximate that the mean would be somewhere around the median, probably within the quartiles there, but Q1 and Q3, but not necessarily. And that's what you can figure out. So hope this makes a lot of sense. Just have a couple of closing comments on box and whisker plots. One thing that you can determine from it is what's called the interquartile range, or the IQR, and we find that just by subtracting Q1 from Q3, as I've indicated here. And what that does is it tells you the range for the middle 50% of the data. A small IQR would tell us that the data is pretty packed in pretty close together. A large IQR would say that it's spread out quite a bit. We had talked before about outliers, and technically finding an outlier is a little bit complicated. You would first calculate the IQR and then multiply it by 1.5 or 1 1/2. Then we add that number to Q3 and we subtract it from Q1 separately. So if let's say that our IQR was 10, we would then multiply that by 1 1/2 and get 15. So we'd add 15 to Q3 and subtract it from Q1. And if any of our values from the data set were larger than Q3 plus 15 or smaller than Q1 minus 15, then that would be an outlier. To go back to the previous lesson with Stephen Curry's basketball shooting, where he had gone from 18 points to 40 points, and then he had a 100-point game, that 100 would be so far outside of the interquartile range, that it would technically be an outlier. For this course, we're primarily just going to use common sense to find outliers. We're just going to look at something and have an idea. Yeah, that really is kind of stepping away from the data, so we're going to throw it away and not even consider it when we're trying to figure out our measures of center or variation. And just one other point, and it didn't come up because of the examples that we looked at. If you have one of the actual data points that's the median, then you're going to make sure that you include it in both the first and the second half of the data while determining Q1 and Q3. So this will happen if you have an odd number of data points. For example, if you have 5 data points, the third one would be your median, and then in order to find the Q1, you would include the first 3 to determine Q1, and the second 3 or the last 3, which includes Q2, to figure out Q3. So that's something that will happen anytime you have an odd number of data points. Most of the examples that we're going to look at will have an even number, so it will kind of avoid this issue, but it is something that comes up. So just wanted to clarify those comments there. Hope this makes a lot of sense. And now you should be pretty comfortable with box and whisker plots.